Yeah, so sometime back I was looking at this ANSI escape code, NC or NSI, however we want to call it. So I came across something interesting. So ANSI escape sequence are standard for in-band signaling, control cursor location, color, font styling, and other options on video, text terminals, and terminal emulators. So this thing was supposed to control these things such as cursor location, color, styling, and other options on text terminals, and by extension, it also works on terminal emulators like ours. Uh, yeah. So if we take a look at this one, we can the history of all this is there. I'll link this in the description. Maybe you can go over it. For now, let's skip to the actual codes for controlling. So these should be quite familiar if you have programmed in any language before. So like slash n is considered a new line, slash is r is for crazy return. You might have seen the word crlf added together, which means in Windows the new lines are crlf, and in Linux it's just lf. So which means in Windows the lines are new lines come with slash r and then slash n for every new line. Whereas in Unix or Unix-like systems like Linux and macOS, so in those cases it's just ls. So and similarly there's T is also for tab. These are some basic escape codes. We can actually, but to be complete, let's test this out. Let's say echo hyphen hello hyphen t world. So you might notice it just treats slash t as a normal character, but to allow this to handle, we can say we can take a look at the main page of echo. Main one meaning the section one, which is the terminal commands, user commands, you can say. So here, this is the flag we're interested in. It's enable interpretation of backslash slash escapes. So this would let echo treat the backslash as an escape character, which means the next character following the backslash would be treated based on the it is treated differently. So if we now echo this line, it adds a tab here. Similarly, obviously we can and as expected, this creates a new line. Yeah. Now these are all there are specific characters like slash n and slash r to return the carriage, and there is a special escape character which is this one, and it is written as 0x1b or x1b in escape sequence, like or 033. So this is important because what comes the next. So obviously these are like specific escape sequence like an MC2. These are, you can take a look at them later. But what we are really interested in is this one, the control sequence introducer commands. This actually handles most of the color and the cursor control commands. So for example, if we see CSI CSI means CSI into the control sequence first. CSI command is the escape slash, and as we just saw, escape is this one, x1b slash x1b. It's a single character, although it's written as two different characters, three different characters after the escape. It is treated as a single character. Okay, now which means CSI command is x1b and then the opening brackets, and then you can say NA, which means cursor up, cursor, and there is cursor down, cursor forward, cursor back, cursor next line, previous, all this. So let's take a look at this one. So CSI and MN semicolon MH sets the cursor position. Move the cursor to row M and column M. The values are one base, so the initial value is, or sorry, sorry about that. So this value is actually at 1 1. Instead of as programmers, we tend to start from 0 0, but this is actually 1 1 in terminal language. So okay, let's try this thing, cursor position. CSI, as we know, is escape slash, and escape is written as x1b. So this is the whole escape sequence. So let's say we say echo hyphen e, of course, because you want to treat the backslash as escape character. Then we say x1b and bracket start, and then n is row, m is for column. So let's say we say go to row number 10, column number 10, h. H is needed, the syntax, and then write hello world. Yeah, so as you can see, this is row number 1, 2, 3, and we can actually verify, but this looks like it's a 10 number row, and it's a column number 10. You can actually verify this. Yeah. So cursor position, that's how you set the cursor position. And the next thing is erase display. Clears part of the screen if n is 0 or missing, clears the cursor to the end of the screen. If n is 1, clears the cursor from cursor to the beginning of the screen. So let's test this one. N is 1, so which means CSI 1j, or echo hyphen e x1b 1j. So this should ideally clear the screen from cursor position, which is this one. This is where the cursor is, and then upwards till here, so it should be cleared ideally. This is cleared, but somehow the cursor didn't move. Okay, maybe we have to do, what we have to do is do this thing and then say x1b and 1 comma 1 semicolon 1h. So this part is for clearing the screen from cursor to the starting position, this up position, this position, and then after that we introduce a new command to move the cursor to row 1 column 1. So this should effectively get us here. Interesting. Maybe because the prompt, this we are adding another line here. Let's test this out. Hello world. So clear the screen from cursor up and then go to 11h, then type in hello world. Yeah, this makes sense, right? So the hello world is written at the starting of the screen. So you can come back later also this one and then type in hello world, it will still do the same thing. Similarly, there is an if n is 2, we clear the entire screen. So this is also helpful. E x1b and 2j should clear the whole screen. And of course, and moves cursor to left on DOS. Okay, this after clearing, the cursor is automatically moved only in the DOS systems. Since we are in Linux, we have to move it ourselves. So clear the screen and move to x1b, go to 1 comma 1h. Then yes, and obviously, like we saw, the enter command that we end this command with, this enter, actually moves the cursor to the next line. So which maybe if we do hello world, you can see the hello world is actually written on the first row, first column. There are more commands which are interesting. Scroll down, scroll up, erasing. We can also erase lines. It's like n is 0. We move. We can create clear from cursor to the beginning of the line to the end of the line. And cursor position does not change. You have to change this manually. The next interesting thing is this one. the select graphics SGR command is again a subclass CSI ANM, but you have to go this link, and here comes interesting parts. So 0 is, or you can see if no codes are given, CSIM is treated as CSI NM 0M. So CSI 0M is basically reset. It resets the whole attributes. Then 1 for bold, 2 for faint, 3 for italic, all this, and then the other things also. 1M. Then there are, you see, you can take a look at all of this, but whatever we're interested in is this one, 30 to 37 says the foreground color. So something like if we do echo -e x1b and then 37, sorry, what was that? 0m is 0 is reset, 37m should be 30, which number is from 30 to 37, so that's 30m hello world. Okay, you might not be able to see on this background, but it's actually set the color to black. Okay, let's also x1b 0m. So what we did is we set the color to 0, 30, which is supposed to be black, and then write down hello world, and after that we reset the color again. So this should effectively give us hello world, and then should come back to our normal color. It doesn't come back. Okay, sorry, I missed one thing. Yes, so if we do this one, we set the color as 30, and maybe try with a different color, maybe 31m and hello world. Then we reset the color again so that everything is left untouched. Cool. So you can see this is the hello world now comes up as red, and obviously we can do something. Let's do this thing. 3, 4, 5, 6, and 7 is kind of it's not exactly, it's white, yes. Okay, so red, green, yellow, blue, some kind of pink, I don't know, and then this is blue is green, green is blue, and the blue mainly should be blue, and then white. So those are the 7 colors. But then you can also see there's this one, which is another interesting thing. We'll come back to this after some time. But there is background color also, 40 to 47, which is the background color. So let's try those. Instead of 36, which is the 31, which is the it's supposed to be red foreground, we just say 41. So 40 to 47 is the, so this should ideally give us a red hello world in a red background. So as expected, this is done. So we can, and obviously we don't need to write hello world, we can basically write, this should also do the same thing. And we can also say okay, clear the set the background as red, then x1b 37 30, let's say this one yellow was 3, so 33m. So this should basically mean set the background as red, and then the foreground as yellow, and then type in hello world, and after that obviously we are clearing resetting everything. Okay, this makes sense now. So it's red background and yellow foreground over the top. Okay, so next thing is their colors. Actually these 30 to 37 colors are you can say basically 8 colors here and 8 background colors here, so which means it's a 16 colors, background and foreground, and obviously maybe bold or increase intensity. This can also be done. So you can basically, I think this is bold, then this is color. Sorry, this is foreground color. Maybe we can actually combine these two. So it is something like X1B 41, but let's say 31 we don't need, and for now we don't need this thing. So you just and this looks bold. Yes, so if we say 0 semicolon 31M, then it becomes a normal text, and if we say 1 semicolon 31M, then it becomes a bold text. And obviously there are italics also, 3 is italics, 4 is underline. Let's try 4. I don't know if this is supported. Okay, this is supported in the Kitty terminal. Okay, and then this is italic. I don't think italic is. I don't think italic is supported. I mean, I have configured. Italic is same because it depends on actually how your terminal fonts are set. In my system, the fonts are set so that italic is basically the same font as this one. So you can basically, I can show you my kitty conf, so you can see the italic font and the normal font is basically it's the same thing. It's the same family, and then it's just the same line. This one you can actually see it's same value. So that's why. But in your terminal emulator, whatever you are using, there you might actually see italic when you say 3 semicolon and then the color information. But let's move on to this. Here we are seeing the color information. The next set the foreground color. But if we go to color, so there are 8-bit colors, 3-bit and 4-bit, which are this one 30. There is a table already, and what does the different terminal shows up, like which Visual Studio Code, the terminal that comes alongside Visual Studio Code, which actual red color is actually shown there. And yeah, so different, this terminal app I think is the macOS terminal. Yeah, so this is the macOS terminal, and the red it shows is here, red component is 153. Every component goes to 255. So 000 is black, 255, 255, 255 is white. Like this one, bright white, 255, 255, 255. It is shown black because the font is white. So if the background is set to white, you'll not be able to see it. Maybe I can. Sorry for the white flash. But this is actually black. This is a white foreground. My colors are shown a bit skewed because I have dark reader on. But yeah, so 30 to 37 and 90 to 97 are also okay. So there 30 to 37 are normal colors, the 8 colors, and then you can also say the bright versions of this. And similarly for background, 40 to 47 is the mm, you know, what's dull colors, or like normal colors, and then these are the brighter versions of the same color. But obviously we are our terminals, we are not working directly in a TTY, we are working on a terminal emulator, so we might actually our terminal also should support these colors. So this is 38.5 nm for select foreground color. N is the number from the table below. So let's see the table number. Okay, these are much more colors. So let's say if we want to 10, let's say maybe 73, which is like a blue green something, 73. So we say echo hyphen e x1b 38, then 38 5. It's not semicolon, it's colon. Okay, colon 5, and then 73M, 73M, hello world, and then X1B, reset again. See, this checks out. You see the same color as this one. Maybe you can try one with maybe somewhat red or orange, maybe 202 is orange. Yeah, makes sense. So these are also 256 color mode, and obviously if we want the default color, standard colors and high intensity colors are also here. Mm, but and grayscale colors are this one. So Python code to generate all the RGB values. This RGB values of all the colors. Don't need that. Yes. Now this is what we are currently living. So 24-bit colors are the standard when you're using a proper display or anything. Our display actually works with 24-bit colors, which basically supports, we can set red, green, and blue components. Each can go from 0 to 255. So red can go from 0 to 255, similarly green and similarly blue. So 0 to 255 is 256 basically, including 0, there is 256 values. And if you the total number of colors available to us is 256 red, and for every red there is also every possible shades of green, and for that there is also every possible shades of blue. So there are red 256 shades of red, 256 shades of green, 256 shades of blue, and we get a little over more than 16 and a half a million, more 16.7 million maybe, a better wording to say this. So 16.77716 million colors, which is quite close to our 20 million colors that are supposedly our biological our eye can see. So this is so, but the thing is, not all terminals or terminal emulators might support this. It should support, it can support, but some terminals are much more minimal, so it might not be supported, or some might even have these 24-bit colors disabled by default. So let's test this thing. Let's something like 382 RGBM. This is 382 for format, and this here this time it's semicolon, not earlier it was colon, but now it's semicolon. 32, I don't know why there's a difference of colon and semicolon between 256 color mode and 24-bit color mode. Anyways, let's test it out. XOE X1B 38 2, and then we have to supply red, green, blue. So red is, let's say, 255 0 0 M. M is there, so which means we are setting red to full intensity and green and blue to 0, so which means it should be a pure bright red, and then we say hello world, and obviously we reset everything afterwards. Great. Now if we set the green as well to full intensity, so red and green mixed up, it will generate yellow. Similarly, if we create, let's say, 255 for blue, and we remove the red component to 0, then this is basically this color. So we can, it practically supports every possible color that your computer can display. And the way to test this is, there's just some terminal variable, actually environment variable, that you can check to know whether your terminal supports 256 color. Of course, you can directly try this command and see, but sometimes if the terminal doesn't support true color, so it will basically fall back to 256 color mode automatically. So to actually know how to do this, color BFG, some terminals URXVT, and the console, let's suppose this is the default terminal emulator for KDE. GNOME terminal, if you state this behavior okay. Then what's a easy way to check color modes? Forget it. Okay. We can maybe check this one actually. Eco color. It's not there. Okay, color. Okay, sorry. Use the separate environment variables dollar color term. So maybe this thing is supported in my terminal, which is Kitty, by the way. Uh, echo true color means, so true color, I think it means it supports the full version. I'm not able to see if there is a mention of true what the true color means, but we'll assume we have full support. But if you want to know, you can actually what was the command again? Color term, true color. Okay. And now, as we know, we can basically say, okay, any color is supported X1B, 38 2 plus 2, right? 38 2 and 48. Okay, 38 2, and we say, let's assume a red color, and then X1B, um, 48 2 is the background, and we set 20 20 20. It should be a gray color, M, and then it's a background, gray background, red, intense red foreground over gray background, and then type in hello world, and obviously we reset everything afterwards. Okay, maybe it's too similar a gray to my terminal gray, so maybe we can say 80 80 m. Yeah, makes sense. So as you can see, this is gray background, and over there is a bright red, this thing. And obviously we can switch the color also. Let's say we want gray foreground and red background. It's not really literally visible, but the wording is there. So now that we know how to do colors, let's try something fun. So cdsrc probe mkdr ansirt. If you don't know what is NCR, I can NSIRT. I have already taken a look at this, obviously. So NCR is a computer art form that was previously widely used in bulletin board system. It is similar to ASCII art, but constructed from a larger set of 256 letters, numbers, and symbols. And you can use multiple symbols. So basically, this is an actual NCR. So these are basically, as you can see this here, some are basically the background color set, and then some are specific characters, and using that they're trying to create the picture like this. This also has a JS semicolon. I think this is just for fun, I guess. JS semicolon, right? Okay, but we can use for now just the space, just this one, something like, okay, we set the color to red background, and then say space 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 5 spaces, and then we set the color, so we get the red background basically. So let's try this out. Let's say let's say main.c and has include stdio.h. Obviously language doesn't matter in this case. We just, as we saw, we can basically echo, use the best built-in echo command also, and you can use any commands, any programming language. We just need to output the output to std out. I'm familiar with C, that's why I'm basically picking this, using this to test it out. So this one, let's say we test it out with printf x1b, set the color 38 to, and then 255 00m, maybe space hello space x1b 0m, and then obviously we add a new line just in case. So we basically set the red foreground and some hello and some basic text. So this should make sense. So the reason I'm going over a proper programming language, I mean, you can also do it in Bash, because you want to employ for loops and all to display something cool over the terminal. So if you know Bash, the for loops and while loops and everything, and you are fluent with Bash, you can also test this out with Bash, but or any other programming language you prefer. For our use case, for this video, I'll be using C. So let's do something. So before doing anything, let's clear the screen. X1b, if you remember, we have 2J was for clearing the screen. I can, okay, I basically uh, okay, okay, this one, mistakenly close the Firefox window, FGV control characters, no, actually this one. And then for clearing the display, if n is 2, clear the entire screen and moves cursor to the, and move, as we checked earlier, we have to do the movement ourselves because only DOS moves, does this automatically for us. So we say x1b2j, which means clear the whole screen, and then x1b 1 comma 1 semicolon 1 h, which means basically go to the this particular character, basically the top of the screen. So we basically set our stage and then say for just think for this we need to know how many lines we have and how many we want. What I want is basically clearing it, setting the whole screen red background, but for now let's say I equal to, or basically y is equal to 0, y less than 10 plus y, loop from for loop 10 times for low, and x equal to 0, x less than 10 plus x, and then we say printf, or we can basically say space. Obviously for this to work, we will initially set the x1b 30 38 was not 48 was for background color to bright red, which is 255, but since we are we can use this color actually, the printf that comes from. Let's take a look at my um, plugin color.vim. I have this function is fdc04b. Okay, this doesn't help. Node 0xfd 253 0xc0 0x4b. So css or any such color, sometimes the RGB values are also written like this, which is fdc04b, or you might also see it in css, it will be written as this one. So if you want the color and convert it to the equivalent decimal values, what we need to do is take groups of two and then open up any if you have node or even Python or any, then you can basically type them out here to this thing. Or otherwise you can also go over the Google out a basic hex converter, hex to decimal converter, and type in this is the hex value. So this should come up as this one. So 253 in our case, 253, 192, and 75. So uh, 253, 192, and 75, and this should be it, right? 253, 192, 75, and then we set the color first. This one is clear screen, move to origin. Origin is top left, then set desired color, and then draw these things, the 10 by 10 area grid with spaces. And since the background is set as red, the space would come up as red. Acc main.c dot let out. This is not what we expected. Okay, for now let's do this. Printf x1b 0m. This is basically reset the reset color attributes. 25175 and then we printf space, and obviously printf slash n also, because we want to uh, for every line of 10 characters that you want we draw, we need to move the cursor downwards also. So yeah, this okay, echo if okay, so x1b 0m clear, reset the terminal. Okay, and then clear the screen. Okay, those less, did we compile or did we not? See, okay, now this makes sense. We are basically a 10 by 10, this is 10 this thing, and 10 columns and 10 rows. My font is basically too much narrow and elongated font, so to match, to try and make a square, maybe we can do 2 spaces or maybe 3 even. Let's test this out, and those less it about. Yeah, this more or less looks like a square. So for every new line, every line, the distance between two, the size of one line is, the height of one line is actually mm, equal to 3, the width of 3 characters. This is great. Now how we, let's say we want to set the whole color with this background. So for this, there is just, but we need to know how many columns and lines are there in our terminal. For this, there is this command csi6n device status report. You basically type output this or print this to the terminal, and terminal will report the cursor position CPR by transmitting this one. So we type in this one and hit print, and terminal will print back this thing. N is the row and M is the column. So let's try this out. Echo -e x1b, what was that, 6n. So is it 3 colon 1? It is writing here. So 0 1 2 3. Okay, it's supposed to be writing here, but I guess it is supposed, it is selecting this position and then outputting it at the next line. So what you can basically do is x1b, we need to move to the this right, but we don't know how to move, so we type in a really large value, which is impossible because the terminal doesn't allow you to move right beyond this part, so it will basically cap it here. So you can say basically 9998, or sorry, we go 999, go to 999 row, 999 column. This was the cursor position command. If you remember correctly, this one is cursor position. Cursor position command CSIN semicolon MH. N is the row, M is the column. So go to 999th row, 999th column, 999 column, and then we ask the terminal for the value, the cursor position. So if we do this, it basically says 28, 26 row and 134th column. We can actually verify this because 26 is 26 and 134. Obviously we don't need to do one because we are typing in three spaces at once, so x should be 134 divided by 3. So gcc main.c.out, and it's basically not this 34 0 134 divided by 3. It's because 134 divided by 3 is not actually, it's something point something, so they are still remaining. So what, for simplicity we can actually say less than equal to, which will give us the same result. Or ideally what we should do is basically call math.ceiling for this. For now this should work, this should work out. Okay, this is not work, doesn't work. 134, because it's 134. Okay, let's do this one, 134, and we type in, forgive my mathematics, for now we do this simple. So 134 columns are there, so we just one space at a time. Obviously this can be made much more performant if we just do that calculation properly. For now let's do this one. We are still okay, we don't need equal because we are counting from 0. This is great, and you might say these two are not set properly, but actually if we scroll up one line, two line, then you can see the whole screen is actually set to this one. Yeah, see, so it's not but every after the command ends, bash actually writes down the prompt. So this is why this comes up. So we can basically, and now we can set any color. Let's say we want, let's a cool color maybe. Let's try in the green color of this terminal. My PPM plugin color.theme, and then string is 30d020, okay, which is, again we go back here, 0x30 which is 48, 0xd0 which is 208, 0x20 32. So 48, 208, 32. F2, this is 48, 208, sorry, and then 32m. Is it 48, 208, 32? So this should give us the greenish color that is in this string. It's used to highlight the string, and we have to compile this again, and yes, makes sense, I guess. Yeah. Okay. Now let's take this up a bit. So what we can do is, now we have the whole palette of these colors, 16 million colors, which is also the same palette used by our image editors, or the image that we use to or image files that are in use. So if we can basically read an image pixel by pixel, assuming it is less than 26 by 134, it's pretty small image, and then instead of doing pixel value, we just write in space with the specified color. So for this, what obviously we will need to take a look at some simple image format, and I have already taken the time to find out this thing. This is net PBM. Uh, it's a very simple format, and we can basically write it, parse it out manually. We can create a parser for this PBM format very simply. So there are three formats: PBM, the bitmap format, then the gray map, and the pixmap. We are concerned with pixmap because it can store full color values. So PGM and PPM. This is P3, and let me just show you out. Let's test this out actually. Let's say we should test dot image dot ppm, and if we paste this, obviously for now we will remove this comment. So what this means is the P3 is the standard header, then 3 and 2 are the basic, it's the resolution of the image. So it means uh, 3 is the width and 2 is the height. So it's 3 by 2. And then the color component, these are the color components, but then you have to first specify what is the maximum value of a single component. So if we say 255, you cannot go beyond this value in this color value. So 258 to 00 is red, then it's green, then it's blue. So you can basically see here red, green, and blue. This is 25500 red, green, and blue. And then the other thing is 258 which is yellow, 258, 258, 258 which is white, and 000 is black. So coming back to this one, if we save this, unfortunately my image viewer that I use doesn't support PPM, but we can do something like convert this magic image.ppm and convert this to test image.jpeg. This should convert this ppm data into jpg, and we can verify, and we can basically see it's shown like this because it is zoomed 46 42,600 percentage. But if we really, it's hard to verify like this way, but it's actually this the same image that is okay. And obviously there is another format also, which is P6 binary format, um, which stores the same thing, but in the last header must be 257 with data immediately following it. So for the binary format, this is obviously textual format. For the binary format, what we need to do is this .ppm. These three lines are same, and then after this part, we don't write this in ASCII. We just write it out in binary. No, directly this thing. So what we can do is we can basically try out a PPM parser. Uh, so let's say main.c, and obviously clear the screen, move to top is obviously do properly, and then we don't need to set this thing, and reset is also going to be same. So in here we need to read this file star file equal to f open. Obviously we can take the file name from the CLI parameters, and you can say if argc is less than 2. Let's do this later. The c is less than 2 or not equal to 2 basically. Then we say f printf std error, say percentage s invalid uses argv0, which contains the program name, and then we say printf std error uses equal to percentage s, then ppm file path, and then we return or exit the program with non-zero error code. So at this point, if this comes here, we are certain there is the program is the file path is basically given as a CLI parameter. So we test out argv1 and read binary. This is, we can take a look at this thing. Fopen, it's the read path, and then the restrict mode is the mode. And mode, if we see, R for text file for reading. And because we want this to work in Windows also, I don't know if anyone will use this on Windows, maybe someone will use it. But for this, we need to ensure we are using binary mode. Uh, it's not required in Unix, but yes, we will. And obviously, we have to check if file is equal to null. Printf std percentage s could not open, or maybe f open, file open failed, and m, which basically will get us the error details in string instead of going and then we say return 1. And if everything is correct, we need to now parse the ppm file. So for this, the first line and obviously we're not going to for now we will assume the file would not contain these comments, and we assume that this is the first line p6, obviously in the binary format. And so let's say char header, this should be p, let's say 3 equal to 0, and then there are image width and height. So in width equal to 0, in height equal to 0, in max component max val x value equal to 0. So then we read, okay, fscanf is the file stream and then the format. Okay, so fscanf, we just say file stream is file, the format is %s followed by a semicolon, then we say percentage d, which is for the width, and then there is a space, then percentage d again for the height, then there is a new line again, then there is a this thing again, and then there is a new line again. And the first value is header, the second value is address of width, storage is address of height, and address of comp max value. Let's test this out first. Close file, and let's print this out. Printf um, header equal to %s header, printf equal to %d x %d, this is with height, printf max component value equal to %d, and this is comp max value. So if, and obviously we need a binary format for this. So obviously how this format would not work. The test image.ppm is in it's in text ASCII format, but since we are only concerned about this thing, we can actually verify if our code works with this file also. So gcc main.c let's say dot out. Obviously it tells, okay, this is invalid uses, you need to add the ppm file, and then we say image.ppm. So header is p3 as expected, dimension is 3 by 2, and max component value is 255. So we are basically we are set. Basically this thing is properly parsing out the header with height component. Obviously, if strcmp compare the string header with p6, if it is not equal to 0, which means they are not same, then we say f printf the error %s not a binary ppm file rgv0 rgv1 return 1, but obviously we need to close the file first. So if it is not this one, we basically we forgot to write include string.h without image.ppm. What the heck is this? Image.ppm. We clear the screen, then we go here and then we read the file. Read the file and then we compare, and then if this doesn't happen, obviously we need to reset this also. Maybe do this something like cleanup, and then we say go to cleanup, close the file, reset the color attribute, and then okay, so it's header image.ppm, not a binary ppm file, which makes sense. So we can only read the binary ppm file. Now how we can get a binary ppm file of a simple image? We can actually convert one from a normal format. So for now, let's copy. I have a rather big file. So in pictures, wallpapers, mountain lake, we show you how what the actual image looks like. So you can basically this one, and its dimension is 1920 by 100 is the image. So we need to reduce its size to something that is fit on our terminal, but obviously we can go lower our font size also. So let's try this. How much low can we go? Actually, echo hyphen e x1b, go to maximum column, maximum column, and then report the distance. It should be 2102, and if we go lower the font size is 24121. If we lower it even more, it will say 33170. So if we go all the way low and then run the command, obviously we will not be able to see, but we can zoom it out. So it says 175 by 852. So 175 is basically the lower of this, and 175 is the line number, the height. Okay, so what we can do is we can convert this image, say resize to, what was the number again? I forgot what was the number. It was 172, right? 175 by 50. So let's copy this. I'll copy this one. So 178 52. This makes sense. Okay, and 125 by 52. Okay, now what we needed to do is convert this image magic resize. This was 1080, so we'd say take whatever number you want for the width, but for height we just need 175, and then we output this to dot slash mountain leg.ppm. So now if we let's say verify this thing, we can actually see P6 311 by 175. So 175 it kept the lower, and 255 is the maximum value, which makes sense. And then there is no comments also. So this, and this is the binary data of the color value. It is all jumbled up, but this is how binary data looks. So don't worry, we'll parse it out manually. And this is P6 header also, so this can basically work. So now if you basically verify a dot out and mount it like the ppm, it doesn't show up the warning saying okay, this is not a this thing. Now we don't need these three things, but and we need to compare this thing, but then we need to for in y equal to 0, y less than image height, which is height plus plus y, and then for in x equal to 0, x less than width plus plus x, we need to read the color information from this one. So let's say color is unsigned int, so int 8 underscore t color, and let this be 3 equal to 0, because for every color, every pixel there'd be three components, and each should be of type uint8t, which is basically 1 by the 8-bit type of unsigned integer, because the color might go to 255. So for this, and then we read fread, forgot fread, maybe fread, fread. The void pointer is the first one. Forget about this. This is some error. I don't know why this comes up in our manual pages. Uh, this is basically a repeat of this line, so I don't know why this comes up. So this is the first parameter, not this one. We can actually verify this with maybe man, what is this, 3 section 3 f read, and man 7 makes sense. This, this again has the same bug. Maybe it's not a bug, it should looks like a bug though. Maybe this one. ah the first pointer, the size, and then okay, this doesn't have a comma. No documentation is actually arc manual. We are already in arc. Maybe this one. This is actually the correct one. Then you have to say that okay, this is color, size is 1 byte, but then there are 3 items, and then the stream is file. So and if this and this should give us the return value is number of items read, so this should be ideally 3. So if this is not 3, we want to stop. If is not equal to 3, we will basically stop this thing. So if even if end of file happens, this will also be 0. There's no more data to read, so this will also basically, or we can say not equal to 3. And then what we need to do is printf x1b 48 for 2 for background color. Then we say percentage d, percentage d. Actually better to write percentage u for unsigned int, m, and then we just type in one space, and the color is color 0, color 1, color 2. and obviously we'll not going to make this mistake again. After every line we write, every row we write, we need to output a new line. So what we are doing is basically we are reading the color information, binary color data, 3 bytes at a time. It's 3 bytes at a time, 1 byte 3 times, so 3 bytes at a time. And if this obviously less than 3 or not equal to 3, we'll basically breaking, because obviously either the file is corrupted or the file is has ended. Uh, we can basically to do handle error slash edge cases maybe. But for now, let's keep things simpler. We have one space and then one, and for every color that we find, we set the color using background color and draw a space, a single space. So the background of the space would be the color that is actually the pixel value of the color. So gcc main.c. Okay, we need to add the std and the header. That out, no mountain like.ppm. So we need to go lower a bit, because obviously this doesn't go lower a bit. Now we can actually see the image. Obviously it's lower. Obviously this is stretched out, and last because my font is too much thin and long, so the width is much less. So what we can do is that might be a joke. Okay. What you can do is we can basically go a bit lower and say for every pixel we just draw 3 spaces, and then we go even lower and then come run the same thing. Okay, we cannot do 3 spaces because this image is too large. Maybe 2 spaces. Huh. Now this kind of looks like the original image, which if you see, um, wallpapers. Now, so this is the original image, and if we do this like 3 1 don't know what I'm doing, 3, okay, and then if we, so this is our rendered image in the terminal, and this is the original image. Quite similar, I think. This is great. But obviously what uh, for simple this image approach works fine, but I have found this thing, a 2D sprite bundle, which has all these animations and all. So let's try this out actually, setting the animations, which is quite simple if we actually see. So download this. You can basically name your own price. No thanks, let's take me to downloads. For now, we, we might not want to use it. I don't have any use for it, but for the sake of demo, let's download this. And this license says we can use it in the personal commercial project. So I would definitely link this in the description, so that if you like this character, you can go to this link, or maybe find out any other characters, other sprites that you need. I have already downloaded this thing, and I have extracted this one. So let me show you what it actually has. So there is a license and preview. This is the preview one. Obviously we don't need the preview one. What we are interested in is the sprites and attack, hard, idle. And if you just take a look at this one is the attack. So 1, 2, 3, 4, 5, 6, 7. The 7 images. If you play them in sequence, if you render them in sequence, it will give you the attack animation. I don't know. Let's look at the run animation. This is the hard, as you can see here, and then this one is idle. This one is run. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 images, and the resolution is 1536 by 96. So 96 is the height and 1536 is the overall width of this image. So we can basically do a simple math. Sorry, I forgot what was the image again. Run the PNG. What was the 1536? Okay. 1536 divided by 16. 96. Let's. It might mean a 96 by 96. This thing. Let's say it's scalable just for verification. 1536 by 16. It's indeed a whole number 96 by 96 image. So this image, every character has 96 by 96 pixels. So what we need to do is we need to crop the images, each image into a separate image file. Then we can basically view individual images as well. So go to this one and we'll say, let's say samurai run frames, and we'll basically store our images there. To split out this thing, I have this commands that I uses the magic image magic tool, somewhere 2, and then sprites, then run.png, and then we say crop, and we want the dimensions to be 96 by 96, and start at 0, x is 0 and y is 0. So you can basically saying start from 0 and 0, go 96 by 96, something like this one, and then crop this particular section. So if we say start from the x has 96, you basically say okay, crop this section. It's the same 96 by 96 section, but the x is basically you can increment x to crop this thing. So obviously we will do some kind of a magic self, and then self. Okay, this is because this is you supposed to escape this. You need to find out this thing. Sprites. Okay. And we say run.png, and then say crop 96 by 96 plus 0 plus 0, and output this to samurai samurai and frames frame 0.ppm. So let's just need to test this if this works. sh pub.sh minus downloads free samurai present 2 sprites run the png. We can basically copy this whole thing just to be exactly sure. So let's just test this thing out. Unable to open image, no such file or directory. Why this is coming up in this one? Text me actually there. We need this one maybe because we are using. Okay, let's do this thing. Copy minus r downloads free image 0.2 and we copy these two and then sprites run.png copy to samurai run.png. So we have imv samurai run.png, and then what we can do is basically instead of doing this we can say /samurai run.png, and obviously we need to do this for every frames. So we copy this and we know there are 16 files 16 pictures in the same image, so we need to crop 16 times 16p, and obviously every time we need to basically do this. So 96 control a and then do the same thing 96 control a no 96 control a 192 and then this thing again 9. Maybe I can use a macro for this, but I'm not so sure about this. 96 control a. No, it doesn't work like this. 96 control a. Then we say 96 control a. 96 control a. We can do. So for verification, if we say calculate 1440 plus 96 1536, which are all the original numbers, so I believe we have not made any mistakes. And obviously we need to also, so frame 1 frame 2 frame 3 frame 4 and up till frame 0 to true frame 60 15. So ideally this should work, and sh crop.sh. So if we see in samurai run frames, there are 16 frame, and obviously if we um, do like imv, and then we can, okay, we cannot view the imv file, but if we say route samurai run frames, let's say frame 7.ppm, and if we scroll this out, yeah, so we are basically seeing this thing. And obviously since we don't need this, so if we say frame 9, we can basically see frame 9. Now what we need to do is we need to animate this. So if we the animation works like this. So we start off by clearing the screen, draw an image, wait some time, sleep some time, and then we clear the screen and draw the next image. So what would have been better is to do in crop.sh instead of this frame. It should have been really better to sort out. Therefore, so then it would be easier to sort this like we want, and we remove samurai run frames star.ppm. We just basically clearing out and doing the cropping again with the proper file name this time, sh crop.sh, and this time if you see ls samurai run frames, we can see this is all sorted by us due to the fact that it's sorted by name basically. So now we need to basically do a dot out um, samurai run frames frame 0.00.ppm, and then we basically sleep for some time, which is, let's say, half a seconds, and then do the same thing for the, the second frame. Obviously, to do this, we can go create something like him and see mason.sh. What we need to do is, let's say dot out, and then samurai run frames frame 00.ppm, and then what we need 00.ppm, and then sleep 0.5, and paste this out 15 times, and obviously we need 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. What, why did it do 7? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 7, 8, 9, and then for this is 10, and then obviously it should be 10, 11, 12, 13, 14, 15, 16. We don't need 16. I don't know why we did it. Done. So basically we're while true. So basically we're running an infinite loop. We do this thing. We draw the first image. We skip the first image actually. Frame 00 is the starting, if I remember correctly. Yes, frame 00 is the starting. Then frame 1, frame 2, frame 3, and then after every frame we are just stopping for 5 seconds. So if we do this and we just zoom this out, somehow this is not working. Okay, we need to scroll this. If we scroll this up, this messes up. Scroll too much up, it messes up the image. We just need to be here to see this, and obviously this is going too slow. So what you can do is mason.sh, and instead of sleeping for 0.5, we just sleep for 0.3 maybe, or 2 maybe. Yeah, so basically we can see the frames being rendered and it's clearing everything and drawing the same frame again and again. Why is it moving too slow though? Maybe 0.1. We did the frame 9, 10, 11, 12, 13, 14, 15. Yeah, this makes much more sense actually to see. Obviously, we can actually do this the whole thing in the for the whole animation. We can do this in C, and what you can do is you can load all the frames in memory once, render it out and store it in render the proper printfs into strings, and then do some optimization so that this the animation is much more faster. But for a use case, I think this this works and this surely looks cool. Great. So that's how you can basically animate an image right in your terminal.